Okay, so hopefully by now you've figured out that with your specific immune defense, antibodies are kind of a big deal. So we should talk a little bit more about kind of what they look like, what they do, how to classify them. So we'll draw kind of a basic looking antibody here. And so with an antibody, you're going to have really two ends you got to keep track of. You have the ends up here that are variable, they change. But there's a reason for that. You need to have all this variety of shapes so they actually lock up with anything that's foreign. And so this is the spot that will have the antigen binding site. Now with the antigen binding site, the shape there is actually locking up, not with the whole antigen, but a specific region of the antigen, which we call an epitope, or an antigenic determinant. This is the end that actually finds stuff that's foreign and then triggers our immune response. Now down on the other end, this right here is going to be our FC region. You can also think of it as your stem or your constant segment. So this is the part that's going to bind with yourself. So this is always the same because it's recognizing what is yourself and helping those cells do their job. So let's start up here first with the antigen binding site. So with an antigen binding site, what are the things that we can do as an antibody specifically at this end? Well, we can neutralize a pathogen. So that basically means, let's say you have some foreign substance coming in, it's got antigens on its surface, you can wrap around it and surround it with these antibodies. And so by wrapping around and grabbing a hold, it can no longer get into a host cell because it's wrapped around with all these antibodies. All of their surface proteins that they would use to dock onto something that is ourself are all used up, and now it can't actually attach to you. So neutralization is one of the options. Another one is agglutination. In the case of agglutination, let's say you have several bacterial cells. You don't want them running around and doing whatever they want. You're actually going to clump them together with several antibodies, and we're going to allow other cells of the immune response to then have access to them. So we're kind of grouping them up and saying, yep, here's the foreign stuff. Now other cells can come in and kill them. So we can get our cytotoxic T cells, our natural killer cells involved. But the job of the antibody here is to group them up. And you're specifically grouping up foreign cells. That is different than precipitation. In precipitation, what you're grouping up are foreign antigens, so something smaller. So again, your same idea here, the antibodies are working to kind of cluster and group these things together so that way it's easier for your other immune cells to find them and defend against them. Just in this case, it's something a little smaller. So the trick I use, if I think precipitation, I think of like rain or snow, which that stuff's small. So that's smaller than the cell one. So cell getting clumped together, that's agglutination. If it's antigens getting grouped together, that's precipitation. So neutralization, agglutination, and precipitation are all functions of the antigen binding site. There are things that we can do, however, also with the FC region. So the FC region can, again, attach to our own cells. So they're going to work with our body, or I guess even our own cells, our own proteins as well. So then we can help get rid of these antigens. So how this will work is this end will still bind to an antigen, but this end is going to then go to something else to kind of get some help. So one option that you're already familiar with, because we used it in our nonspecific defense, is opsonization. With opsonization, let's say you have a bacterial cell with antigens on their surface, so you can recognize it as foreign. Our antibodies can then attach to those antigens and give little handles, so it's easier for our phagocyte to come in and eat it, because then the phagocyte has some proteins on their surface that the FC region can bind to. So the FC region binding to our phagocyte to help it engulf that foreign bacterial cell. So opsonization is one thing. We can also do complement fixation. With complement fixation, you're going to then have the FC region bind to a complement protein. So here's our antigen sitting on our antibody. So we have an immune complex here that we need to get rid of. So we need to get it to a place that has a lot of white blood cells so it can do its job and help destroy it. We can do that by hitching a ride on a really common cell that's already transporting things in the body, a red blood cell. So let's say we have a red blood cell floating around. We can then take the Fc region here and we can attach to a complement protein. So that complement protein then will serve as the bridge to attach to the red blood cell, which will work just kind of like a little truck, so it's going to hitch a ride. So our red blood cell here, I guess I could probably label that, can then take us over to the liver, the spleen, where you have a high concentration of white blood cells, so then you can destroy that antigen. And let's maybe even say that that antigen is attached to a bacterial cell, so it could even be even bigger than just an antigen. So we have that immune complex here with the antibody, the antigen getting attached at the Fc region using a complement protein to a red blood cell. Our third thing that we can do with the Fc region is activation of natural killer cells. So natural killer cells are part of our nonspecific defense, but they're really effective. So let's say, again, we have our antibody holding on to a bacterial cell, so something that's foreign, by its antigen. And we're going to then have this Fc region attached to the natural killer cell. So there's our Fc region kind of going over, attaching to a binding site to say, yep, look what I found. So now our natural killer cell can release granzymes and perforins to then kill off that bacterial cell. So you're doing different things at each region. So remember, antigen binding site up here at the top of the Y, that's for attaching to something that's foreign. Fc region, those are constant. Those are going to attach to things that are our own proteins. So like phagocytes, surface to help make things easier to engulf, attaching to a complement protein so it's easier to attach it to something that can take you to a liver or spleen, or attaching to a natural killer cell so you're kind of like holding this in place so it can then release its toxins versus like it trying to chase it down and like throw things at it. Think of it kind of like anchoring or docking in that pathogen. Now, there are different ways of classifying them. They don't all look like this. So the classifications are more about the shapes that you can get out of the variety, or the variety of shapes that you can get. So let's talk about some options here. So with your immunoglobulins, that's the full fancy name of an antibody, we have IgG, IgA, IgM, IgE, IgD. It's gamed. Did we all see that? So when you can organize things in a way that will kind of pull a pattern out to you. So gamed, G-A-M-E-D, get you all of the different varieties that you have of your antibodies. Now, what does each do? This is another thing that you can do. So the G kind of does it all. So if you have a G, you can do everything that we list over here. If you have an A, you can do neutralization, and you can do agglutination. If you have M, you can do neutralization, agglutination, and complement fixation. So once I know the pattern, then I can come up with something weird that helps me remember. So if I know it's gamed in order, then I go all NAC. I don't know why, but that sticks with me. So all NAC gets you at least what the first three are up to. If you think of an E, think of allergies. So it's going to have a role in kind of that histamine inflammation. So you're going to deal with things like mast cells and basophils. But also eosinophils, they also pull a role into immune responses with inflammation and histamine. But specifically, it's on the surface of the basophils and the mast cells. The eosinophils, it kind of deals with the inflammation when you're dealing with like a pathogens like a worm. So remember, eosinophils are really good at parasitic worm infections. So we can activate them, but directly IgE antibodies are on basophils and mast cells. Now the IgD has a role with B cells, so it has a role in B cell activation. So we activate B cells because they're on the surface of B cells. And so I don't know if it helps you, but this is kind of how I do it. If I look at the letter B, it's not a far jump to go from B to D. And so I think of the B and the D go together because it's the closest looking letter to the letter B. All right, everyone, I hope that helps you understand a little bit more about the antibodies and how you can use them. What parts are going to attach to something that's foreign, which parts are going to attach to something that's self, and the different ways to classify them. Thanks for watching.